Okay, just now we have already gone through the general process of doing a supervised machine learning. Well, it seems that it is super easy, and probably it is. Well, one thing I have been saying a lot is now with the machine learning get cheaper and cheaper. Now I can teach my grandma how to do some machine learning in half an hour, for example. So since the machine learning is getting cheaper, why in the job market people are still getting a good salary as data scientists? So why? Well, in this process, actually, we have multiple things we just oversimplified, and actually, it can be very hard. And those are the parts that data scientists will spend a lot of time on in the real life. So, what are they? So, think about that. So, the number one thing should be acquiring the data. So I just did a toy data, right? So it is just a 5 by 2 matrix as the x matrix and a vector of 5 values as the y values. So this is oversimplified. And in the real life, if you want to get some data you really want to work with, sometimes it can be really hard. Well, it could be one, it's really hard to find the right data you want to use in order to answer your questions. So in some corporations, the data is there, but how you can get access to that could be really challenging. You have to jump through many hoops in order to really put your hands on this kind of data. And number two, well, the data is not perfect. Sometimes you have the data, but the data need to do a lot of cleaning or massaging before you can really do that. So what else? What else have we oversimplified in this process? So let me go down. Oh, the next thing is the model. Okay, it's actually here. So we just created a model called linear regression and we only specify one parameter. But for some of the machine learning models, you have to specify the right parameters in order to get reasonable results. So if you just create a machine learning model without specifying any hyperparameter, and then all the default hyperparameters will be used. In this case, you may have the machine learning model still running and give you some result, but that result doesn't make sense. Well, some of the results may even be worse than a random shot. And if you see that, there is something definitely wrong. So later in this semester, we are going to learn how we can tune a machine learning model. So what else? What are the parts could be harder? So the next part is here. So how do you evaluate your model? So just now we have the y-test and we know the value is a 0 and 2. And we did our prediction and the prediction is some value super close to 0 and then 2.0. So well, by just eyeballing those values, we know they are the right values. So we have a perfect model. But in reality, we ain't gonna have a perfect model. And if so, if our model is not quite perfect, how do we evaluate the result? Do we say our model itself is already reasonable, or it is something we want to improve? Well, even harder. For some of the cases, you develop your own algorithm, and then how do you justify your algorithm is better than some of the existing ones? This means you have to develop a benchmark by yourself first, and then you want to get some bench up results from some really common, really basic algorithms, and then using your own fancy algorithm, and you can say, okay, my splendid algorithm beats all the benchmark algorithms, so I win. My model is the best model. So this is the evaluation part, and this is also very important. So those are a few things we oversimplified in this process. In the real world, Well, even though scikit-learn or some other machine learning packages have made the machine learning much easier than 10 years, 15 years ago, well, you need to still understand a lot of things in order to qualify to be a data scientist so that you can earn a lot. So I will see you in the next video.